Hi, in this video, I'll talk about GCP Professional Cloud Architect exam format, different case studies, and I'll pick 20 questions and I'll walk you through how to approach any question, how to pick the right answer, and along the way, I'll give you tips and tricks. In terms of the exam itself, it's a professional cloud architect exam. So there is more stress on how to design, develop, and manage a completely robust, secure, and scalable solution on Google. When it comes to the exam format, it's a 2-hour length. Registration fee is $200. It's available in English or Japanese, and the exam format is multiple choice or multiple select. But when it's multiple select, it will tell you that select 2 or select 3. Exam delivery method, given the COVID times, online proctored exam is probably the best option, and there are no prerequisites for this exam. Now, as part of the exam, Google has published 4 case studies, and some of them have recently changed, so keep a note of that. Now, these case studies are very important, and it's really important that before you go and take the exam, you have gone through these, and most of the times you memorize at least the problem statement of each one of these case studies. I have a detailed video where I'm talking about each and every case study and its possible solutions. But for the context of this video, I'll just quickly tell you, like EHR Healthcare, which is about cloud architecture for on-prem to cloud migration solution and scale problem. Helicopter Racing League, which is a kind of a cloud AI and ML telemetry and streaming problem. Teram Earth, which is in cloud automation, operations, and API ecosystem problem. Mount Kirk Games, that's a cloud auto scaling and gaming analytics problem. And this is the kind of format I have described these case studies in detail in the other video, which is very useful to grasp the problem statement and what's the business and technical requirement for these case studies. In my opinion, knowing these case studies in detail almost saved me 50% of time. So it's really important that you clearly understand their business use case and their technical requirements, because it does help you a lot. So now let's straight jump into question. So question 1 is: anonymous user from all over the world access a public health information website hosted in an on-premises EHR data center. The servers that host this website are older, and users are complaining about sluggish response time. There has also been a recent increase of distributed denial of service attack towards the website. The attack always come from the same IP address ranges. EHR management has identified the public health information website as an easy, low-risk application to migrate to Google Cloud. You need to improve access latency and provide a security solution that will prevent the denial of service traffic from entering your VPC network. What should you do? Security related question. I think it's very clear what they are asking for. So if we go through the answers, so let's look at the first one. Deploy an external HTTPS load balancer, configure VPC, firewall rules, and move the application onto compute engine virtual machine. This is not correct, because firewall rules do not block malicious traffic into a VPC, but they block it at the VM level. So the combination of words, that VPC firewall to HTTP load balance, doesn't really solve it. Now let's look at second option. Deploy an external HTTPS load balancer, configure Google Cloud Armor, and move the application onto compute engine virtual machines. Now, this seems right, because external HTTP load balancer will improve access latency, and Cloud Armor can be configured to block the DDoS attack. So let's park this one and let's look at C. Containerize the application and move it into Google Kubernetes Engine. Create a GKE service to expose the pods within the cluster and set up a GKE network policy. It's not correct because a GKE service does not expose a set of pods outside of a cluster. And a GKE network policy only filters traffic between pods and services. So this one is definitely not the right answer. The next one is containerize the application and move it into Google Kubernetes Engine. Create an internal load balancer to expose the pods outside the cluster and configure identity-aware proxy for access. D is not correct because GKE's internal load balancer will not load balance external traffic. An anonymous user need access to the website, so IAP is not a fit. So given all of these options, you can clearly tell B is the right answer. It's because there was a purpose-built use case for Google Cloud Armor to fend off the DDoS attacks. Let's look at the next one. EHR wants to connect one of their data centers to Google Cloud. The data center is in a remote over 100 kilometers from a Google-owned point of presence. They can't afford new hardware, but their existing firewall can accommodate future throughput growth. They also share these data points. Servers in their on-premises data center need to talk to Google Kubernetes Engine. Both on-premises servers and cloud resources are configured with private RFC 1918 IP addresses. The service provider has informed the customer that basic internet connectivity is a best effort service with no SLA. Now, I think this is, if you know about the interconnect options, this is a very simple question. Provision carrier peering is not correct because it does not give private IP addressing across the connections. Provisioning a new internet connection because even that will not provide you RFC 1980 communications by itself. Provision a partner interconnect connection. So looking at the question, it's trying to look at the solution from the interconnect point of view. Now, interconnect has two options, either partner or dedicated. But for a dedicated, you need to be close to one of the Google's co-host locations. So in this particular case, it's in a remote over 100 kilometers from a Google-owned point of presence. So because they are far away from Google-owned point of presence, the only option they have to go through a partner interconnect connection. So C is the answer. Let's look at the next one. It's one of EHR's healthcare customer is an internationally renowned research and hospital facility. Many of their patients are well-known public personalities. Sources both inside and outside have tried many times to obtain health information on these patients for malicious purposes. The hospital requires that patient information is stored in Google Cloud storage buckets not leave the geographic areas in which the buckets are hosted. You need to ensure that information stored in cloud storage buckets in the Europe West 2 region does not leave that area. What should you do? Encrypt the data in the application on premises before data is stored in the Europe West 2 region. This doesn't really solve the problem because encrypting the data does not stop data exfiltration. Option B, enable virtual private network service controls and create a service perimeter around the cloud storage resources. Now, this seems to be correct because VPC service controls improve your ability to mitigate the risk of data exfiltration from Google Cloud services. Now let's look at the next one. Assign the identity and access management storage.object viewer role only to users and service accounts that need to use the data. This is not correct because IAM roles deal with identity-based access control, not context-aware perimeter security. And that's exactly, is what question is asking for. So C is definitely not an option. Number D, create an access control list, ACL, that limits access to the bucket to authorized users only and apply it to the buckets in the Europe West 2 region. It's not correct because cloud storage ACLs are a mechanism you can use to define who has access to your buckets and objects, as well as their level of access. ACLs do not stop data exfiltration. So based on all of these options, B is the right answer. Next one, the EHR sales employees are a remote-based workforce that travels to different locations to do their jobs. Regardless of their location, the sales employees need to access web-based sales tools located in the EHR data center. EHR is retiring their current VPN infrastructure, and you need to move the web-based sales tools to a Beyond Corp access model. Each sales employee has a Google Workspace account and uses that account for single sign-on. What should you do? Now, the first one is create an identity-aware proxy connector that points to the sales tool application. It seems to be the right answer because identity-aware proxy connectors allow you to manage access to HTTP-based apps outside of Google Cloud. So I think this is the right answer, but let's look at B as well. Create a Google group for the sales tool application and upgrade that group to a security group. It's not correct because Google groups by themselves do not grant access to an application, nor they move an application to a Beyond Corp model. C, deploy an external HTTPS load balancer and create a custom Cloud Armor policy for the sales tool application. It's not correct because Cloud Armor does not authenticate or authorize application access. Cloud Armor is mainly used for fending off DDoS attacks. D, for every sales employee who needs access to the sales tool application, give their Google Workspace user account the predefined App Engine Viewer role. It's not correct because application is installed in the data center, not in the App Engine. So this is definitely not the right answer. So A is the right answer. The next question, you are the data compliance officer for Mount Kirk Games and must protect customers' personally identifiable information. Mount Kirk Games wants to make sure they can generate anonymized usage reports about their new game and delete PII data after a specific period of time. The solution should have minimal cost. You need to ensure compliance while meeting business and technical requirements. What should you do? So this particular one, it's all about you just how you store data. Let's look at option A. Archive audit logs in cloud storage and manually generate reports. That's not correct because cloud storage is an object storage with no query language access, which you can use to generate reports. So, sorry. Now, Write a cloud logging filter to export specific data ranges to PubSub. This is not correct because it does not address log storage for data retention. Archive audit logs into BigQuery and generate reports using Google Data Studio. And this seems like the best option up until now, because BigQuery allows easy querying for report generation with low storage costs. Number D, archive user logs on a locally attached persistent disk and CAD them to a text file for auditing. It's not correct because long-term storage in persistent disk is very, very expensive. So C is the right answer. Now let's look at next set of questions. Monker Games wants you to make sure their new gaming platform is being operated according to Google's best practices. You want to verify that Google recommended security best practices are being met, while also providing the operations team with the metrics they need. What should you do? So this is an example of multi-select where it is telling you to choose two. Ensure that you aren't running privileged containers. So A is correct because this is high priority, according to a Google-based practices. Ensure that you are using obfuscated tags on workloads. It's not correct because tags should be readable and useful to the operations team when they are working on the cluster. So this is not the right answer. Ensure that you are using the native logging mechanisms. This one is correct because this is high priority according to Google best practices. D, ensure that workloads are not using security context to run as a group. It's not correct because that may be required for some other workloads. Ensure that each cluster is running GKE metering so each team can be charged for their usage. Not correct because although from a business process this may be useful, it won't impact the operations or security of the cluster. Now let's look at the next one. You need to implement virtual private cloud service controls for Monker Games. Monker Games wants to allow Cloud Shell usage by its developers. Developers should not have full access to managed services. You need to balance these conflicting goals with Monker Games business requirements. What should you do? Use VPC service control for the entire platform. Not correct because VPC service controls do not directly affect scaling of Google Cloud Architecture. Prioritize VPC service controls implementation over Cloud Shell usage for the entire platform. B is not correct because a security parameter is not a business requirement, but rapid iteration is. C, include all developers in an access level associated with the service perimeter and allow them to use Cloud Shell. C is not correct because it works but does not scale. And we don't want to give users this much access. D, create a service perimeter around only the projects that handle sensitive data and do not grant your developers access to it. D is definitely correct because VPC service controls protect data and Cloud Shell facilitates rapid iteration of Google Cloud architectural changes. Next one, your new game running on Google Cloud is in public beta and you want to design meaningful service level objectives before the game becomes generally available. What should you do? Define one SLO as, and while we are at SLO, just make sure before the exam you look at SLA, SLO and SLI concept, which is the service level acceptance, objectives and indicators. Define one SLO as 99.9% game server availability. Define the other SLO as less than 100 millisecond latency. It's incorrect because it doesn't clearly define how to measure both the availability and latency. Define one SLO as service availability, that is same as Google Cloud's availability. Define the other SLO as 100 millisecond latency. It's incorrect because Google Cloud availability has an impact on customer availability. But it is only one factor. Also, for different Google Cloud products, the availability could be different. Define one SLO as 99% HTTP request, return the 2xx status code. Now that's a valid SLO because that's something which can be measured. Define the other SLO as 99% request, return within 100 milliseconds. So it is correct because it clearly defines the service level indicators and how to measure them. So the most important thing is that you should be able to measure it. So 99% HTTP requests, return the 2xx 200 series status code. Define the other SLO as 99% request. Both of them are measurable. So that's right. Define one SLO as total uptime of the game servers within a week. Define the other SLO as the mean response time of all HTTP requests that are less than 100 milliseconds. It's incorrect because there is no objective for the server uptime. Next one, the HRL, which is the Helicopter Racing League, wants you to help them bring existing recorded video content to new fans in emerging regions. Considering the HRL business and technical requirements, what should you do? Serve the video content directly from a multi-region cloud storage bucket. It's not correct because multi-region cloud storage buckets, they do not serve all global areas with similar latency. Use Cloud CDN to cache the video content from HRL's existing public cloud providers. That's definitely the right option because CDN are meant for these kind of use cases. Use Apigee Edge to cache the video content from HRL's existing public cloud providers. It's not correct because Apigee Edge is not designed to cache data and larger than 512 kilobyte. So it's definitely not the right option. Replicate the video content in Google Kubernetes Engine clusters in regions close to the fan. It's not correct because replicating the video content introduces unnecessary complexity. So B is the right answer. You are the data compliance officer for Terram Earth and must protect customers' personally identifiable information, like credit card information. Terram Earth wants to personalize product recommendations for its large industrial customers. You need to respect data privacy and deliver a solution. What should you do? Use AutoML to provide data to the recommendation service. It's not correct because AutoML does not inherently provides data de-identification. It's just a recommendation service. Process PII data on premises to keep the private information more secure. That's definitely not the right answer. Use the cloud data loss prevention API to provide data to the recommendation service. Again, this is definitely the right answer because cloud data loss prevention is the service meant for that. Now, just based on this, remember, it's very important that you sort of have a cheat sheet where you have the specific use case of each one of these products, because most often in questions it will try to give you a use case and try to test your ability if you can map those use cases to any specific product that Google has. And that this is a classic example of that that thought process. So C is definitely the answer. Manually build, train, and test machine learning models to provide product recommendation anonymously. That's definitely not the right answer. So now let's look at the next one. You are designing a future-proof hybrid environment that will require network connectivity between Google Cloud and your on-premises environment. You want to ensure that the Google Cloud environment you are designing is compatible with your on-premises networking environment. What should you do? Use the default VPC in your Google Cloud project. Use a cloud VPN connection between your on-premises environment and Google Cloud. It's not correct because the default VPC is a VPC with auto mode IP ranges. Then B, create a custom VPC in Google Cloud in auto mode. Use a cloud VPN connection between your on-premises environment and Google Cloud. It's not correct because the auto mode IP ranges, there's no guarantee that the IP ranges will not overlap with your on-premises environment, either now or in the future. Create a network plan for your VPC in Google Cloud that uses CIDR ranges that overlap with your on-premises environment. Use a cloud interconnect connection between your on-premises environment and Google Cloud. It's not correct because to ensure correct routing, ranges cannot overlap between environments. Create a network plan for your VPC in Google Cloud that uses non-overlapping CIDR ranges. So CIDR ranges which are non-overlapping, these are the keywords you are looking for. So yeah, this is definitely the right answer. With your on-premises, use a cloud interconnect connection between your on-premises environment and Google Cloud. And sometimes these answers tell you how do you approach this problem. So if you read the question, there were two things. It's primarily basically you need to make sure the environments are compatible between on-premise and cloud. Now for on-premise and cloud, definitely the first thing you gotta look at the cloud interconnect, which is here. That's it. So out of these two, now they need to coexist and interact with each other. That means they have to have a separate IP range. So this is clearly non-overlapping, basically sums up the answer. So D is the right answer. Let's go to the next one. Your company wants to track whether someone is present in a meeting room reserved for a scheduled meeting. There are 1,000 meeting rooms across 5 offices on 3 continents. Each room is equipped with a motion sensor that reports its status every second. You want to support the data ingestion needs of this sensor network. The receiving infrastructure needs to account for the possibility that the devices may have inconsistent connectivity. Which solution should you design? Now this situation, it's definitely, somewhere you're looking at a streaming of data. So have each device create a persistent connection to compute? Definitely no, this is not the answer. Have devices fall for connectivity to Cloud SQL? Definitely again no, because this doesn't fall into streaming kind of solution. Have devices fall for connectivity to PubSub? Yes. And publish the latest message on a regular interval to a shared topic for all devices. Have devices create a persistent connection to an app engine? Again, no, because this is not really a streaming use case for receiving messages. So C is the answer. Your company wants to try out the cloud with low risk. They want to archive approximately 100 terabytes of their log data to the cloud and test the serverless analytics features. So, this is the keyword, serverless analytics features. So anytime you see this word, it's referring to BigQuery. Available to them there, while also retaining data as a long-term disaster recovery backup. Now, the long-term disaster recovery backup solution on Google is cloud storage. So which 2 steps should they take? You can just scan through it and you would know. Load logs into BigQuery and upload log files into cloud storage. The next question, your organization has a 3-tier web application deployed in the same Google Cloud virtual private cloud. Each tier, web API and database, scales independently of the others. Network traffic should flow through the web to the API tier and then onto the database tier. Traffic should not flow between the web and the database tier. How should you configure the network with minimal steps? Add each tier to a different subnetwork. It's not correct because the subnetwork alone will not allow and restrict traffic as required without firewall rules. Set up software-based firewalls on individual VMs. That's not correct because this adds complexity to the architecture and the instance configuration. Add tags to each tier and set up routes to allow the desired traffic flow. It's not correct because routes still require firewall rules to allow traffic as requests. Additionally, the tags are used for defining the instances the route applies to and not for identifying the next hop. Because the next hop is either an IP range or instance name. But in the proposed solution, the tiers are only identified by tags. D. Add tags to each tier and set up firewall rules to allow the desired traffic flow. D is correct because as instances scale, they will all have the same tag to identify the tier. So D is the answer. Next one, you set up an auto-scaling managed instance group to serve web traffic for an upcoming launch. After configuring the instance group as a backend service to an HTTP load balancer, you notice that virtual machine instances are being terminated and relaunched every minute. The instances do not have a public IP address. You have verified that the appropriate web response is coming from each instance using the curl command. You want to ensure that the backend is configured correctly. What should you do? Ensure that a firewall rule exists to allow source traffic on HTTPS to reach the load balancer. This is not correct because the issue to resolve is the VMs being terminated, not access to the load balancer. B. Assign a public IP to each instance and configure a firewall rule to allow the load balancer to reach the instance public IP. It's not correct because this introduces a security vulnerability without addressing the primary concern of the VM termination. C. Ensure that a firewall rule exists to allow load balancer health checks to reach the instances in the instance group. C is correct because health check failures lead to a VM being marked unhealthy and can result in termination if the health check continues to fail. Because you have already verified that the instances are functioning properly, the next step would be to determine why the health check is continuously failing. So C is the right answer. Let's look at D as well. Create a tag on each instance with the name of the load balancer. Configure a firewall rule with the name of the load balancer as the source and the instance tag as the destination. This is not correct because the source of the firewall rule that allows load balancer and health check access to instances is defined IP ranges, not a named load balancer. Tagging the instance for the purpose of firewall rules is appropriate, but would probably be a descriptor of the application and not the load balancer. So C is the answer. Now let's look at the next one. You are designing a large distributed application with 30 microservices. Each of your distributed microservices needs to connect to a database backend. You want to store the credentials securely. Where should you store the credentials? In the source code? Definitely not. In an environment variable? Maybe, but not basically in the cloud world. In a secret management system, yes, that is the right place, because a secret management system such as a secret manager is a secure and convenient storage systems for APIs, API keys, passwords, certificates, and any sensitive data. Secret Manager provides a centralized place and single source of truth to manage access and audit access across Google Cloud. In a config, number D, in a config file that has restricted access through ACLs, again, that's not the right use case. So C is the answer. Next question, your customer is moving their corporate applications to Google Cloud. The security team wants detailed visibility of all resources in the organization. You use Resource Manager to set yourself up as the organization administrator. Which IAM roles should you give to the security team while following Google recommended practices? Organization viewer, project owner. It's not correct because project owner is too broad. The security team does not need to be able to make changes to projects. Organization's viewer, project viewer. This is ideally the best roles from the security team point of view, because they just need to be able to look at the details. So B is definitely correct, because organization viewer grants the security team permissions to view the organization's display name. Project viewer grants the security team permissions to see the resources within the projects. C, organization administrator, project browser, is not correct because organization administrator is again too broad. The security team does not need that. D, project owner, network administrator. Again, network administrator is too broad and this is not required for security team. Let's look at next question. To reduce cost, the director of engineering has required all developers to move their development infrastructure resources from on-premises virtual machines to Google Cloud. These resources go through multiple start-stop events during the day and require a state to persist. You have been asked to design the process of running a development environment in Google Cloud while providing cost visibility to the finance department. Which two steps should you take? Now again, you can see here it's a choose two, which is a multi-select kind of question. The first one, use persistent disk to store the state. Start and stop the VM as needed. This seems like a valid option because persistent disks will not be deleted when an instance is stopped. So this is definitely one of the right answers. Use the gcloud auto delete flag on all persistent disks before stopping the VM. It's not correct because the auto delete flag has no effect unless the instance is deleted. Stopping an instance does not delete the instance or the attached persistent disks. Apply VM CPU utilization level and include it in the BigQuery billing export. It's not correct because labels are used to organize instances, not to monitor their matrix. D, use BigQuery billing export and labels to relate cost to groups. It's correct because exporting daily uses and cost estimates automatically throughout the day to a BigQuery dataset is a good way of providing visibility to the finance department. Labels can then be used to group the costs based on team or cost center. So D is the second answer. E, store all state in a local SSD. It's not correct because local SSDs will definitely be lost when the instance is stopped. So A and D is the right answer. So next question, the database administration team has asked you to help them improve the performance of their new database server running on Compute Engine. The database is used for importing and normalizing the company's performance statistics. It is built with MySQL running on Debian Linux. They have an N1 standard 8 virtual machine with 80 GB of SSD journal persistent disk. What should they change to get better performance from this system in a cost-effective manner? Increase the virtual machine's memory to 64 gigabytes. Not correct because increasing the memory size requires a VM restart. Create a new virtual machine running PostgreSQL. It's not helpful because they're looking for MySQL, not PostgreSQL. So this one is irrelevant. Dynamically resize the SSD persistent disk to 500 gigabytes. Now that makes sense because persistent disk performance is based on the total persistent disk capacity, which is attached to the instance, and the number of virtual cores or virtual CPUs that the instance has. Implementing the persistent disk capacity will increment its throughput and IOPS, which in turn improve the performance of MySQL. So number 3 is definitely the right answer. Migrate their performance metrics warehouse to BigQuery. This doesn't really solve the problem. It can give an insight into what's going on, but this is not. This doesn't give a solution. So I hope this was useful. My main intention is actually to give you a flavor of real questions that come on Google exam, and how do you look at the solution? How do you approach it? Always look for those distinctive clues as part of the questions and as well as part of the answers, which group them together. Again, as you have seen, lots and lots of questions are based on case studies. So make sure you know all of those 4 case studies by heart. I have a separate video which has all of those case studies defined in detail along with the possible solutions for different scenarios. So with that, I hope this was useful and good luck for the exam. Thank you.